In order to evaluate this difference quotient, we first need to get it into a form that mirrors the definition of the derivative, and then we can figure out what function we're dealing with and what value we need to evaluate that at. So the first thing we're going to do is to take the 3 that's in the denominator and move it out in front and make it a coefficient in this fraction. Saying 1/3 times e to the h minus 1 over h. We can then bring that coefficient out in front of the entire limit and change it to 1/3 times the limit as h approaches 0 of e to the h minus 1 over h. Now in this case, because we're dealing with e, we're going to change 1 into e to the 0 so that we're matching the form. And we can complete our transformation into the definition of the derivative by making this into e to the 0 plus h minus e to the 0 over h. Now that we have our difference quotient in the correct form, we can figure out what function we're dealing with, as well as what value we're plugging into that function. So in this case, the function we're working with is e to the x, and the value that we're plugging in is 0. So we have e to the 0 plus h minus e to the 0 over h. So if f of x is e to the x, and our x in this case is equal to 0, what we're looking for is f prime of 0. We can begin by finding f prime of x, which is the derivative of e to the x, which is just e to the x. And we can then find f prime of 0 by plugging 0 into the derivative function, remembering of course that we factored out a 1/3 in the beginning of our problem, and we need to take that into account for our final answer. So we're looking at 1/3 times e to the 0, which is the same thing as 1/3 times 1, which will give us our final answer, which is the limit is equal to 1/3.